Lesson 10.1. The last thing we're going to look at today is permutations with repetition. The number of distinguishable permutations of n objects where one object is repeated s sub 1 times, another is repeated s sub 2 times, and so on, is given by the formula there. That's kind of crazy to understand, so let's go ahead and look at our first example, and I'll first talk to you then about what permutations with repetition means. Number 6 says, find the number of distinguishable permutations of the letters in Miami. So what we're looking at here is distinguishable permutations, which is what this permutations with repetition is all about. In other words, if I go through and order the letters in Miami, and you know what I mean by that. I can say M-I-A-M-I. Let's say I flip the first two letters. So I-M-A-M-I is the second one. Now let's say all I wanted to do here when I'm going through my list is flip the first and the last letter. I-M-A-M-I. I flipped the I's, but it ends up being the exact same thing as the one before. In other words, these two are not a distinguishable permutation. They're not different. So what we need to do is go through and remove those. Okay? We need to remove the ones that would be the same. So to do that, we need to follow this formula. So n is the number of objects there are. So in the first case, n is going to be 5, because there are 5 letters in Miami. S sub 1 is going to be the number of times one of your objects is repeated. So if I look at Miami, I have 2 M's. So we'll say S sub 1 is 2, because there are 2 M's. I also have another object that is repeated, so I'm actually going to have an S sub 2 in this case. S sub 2 we'll use for the I's. There are also 2 I's. When I plug this into the formula, I have 5 factorial over 2 factorial times 2 factorial. And again, you can plug that into your calculator, or you can do it by hand. Either way, there are 30 distinguishable permutations of the letters in Miami. When we move on to Tallahassee, the first thing we need to do is look at n. In this case, n is 11, because there are 11 letters in the word Tallahassee. When I look at it, we'll say S sub 1 stands for the L's. There are 2 L's repeated. I'll also have a second one, which could be the A's. There are 3 A's. I also have another. We can stand for the S sub 3 can stand for the S's, which there are 2 S's. And I'll also have an S sub 4 in this case, which is the E's. There are 2 E's. When I plug this into the formula, I will have 11 factorial over 2 factorial times 3 factorial times 2 factorial times 2 factorial. And when I do that, there are 831,600 distinguishable permutations of the letters in Tallahassee. If we were not to use this formula and simply used what we learned before, we would have many more permutations of the letters in Tallahassee, but some of them, as we talked about in the beginning, would repeat.